Now let us discuss about some of the basic gear terminologies which we have to use in our analysis of gears. Right. So in this diagram we are showing these are the two teeth of the gears. Now let us describe what are the various circles which are drawn here. This top circle which is connected with the top surface of these gears, this circle is known as addendum circle. This is known as addendum circle. Right. This circle is your pitch circle. We will discuss what do we mean by pitch circle and what is the significance of pitch circle. Just right here, this is a pitch circle. This circle, the third one, this one is your clearance circle. Clearance circle. And the last, this circle which is connected with the root of the gear teeth. This is the root of the gear teeth, end of the gear teeth. This is known as dedendum or you can say root circle. Dedendum or root circle. So these are the four circles which are shown here. This first one which is connected with the top surface is addendum circle. This second circle is the pitch circle. This is clearance, and this is your dedendum circle which is connected with the root of the gear teeth. Now we can say that if we talk about, let us say, if we talk about this width of the gear in this plane perpendicular to the plane of paper, this is known as your top land. This is known as top land, and the width of this top land, this distance, this width is known as face width. This is known as face width. Right, face width. Face width. Right. Now, suppose at this pitch circle, if I make this gear in two halves, right, at this pitch circle, suppose we have this line, let us say this line, at this pitch circle I divide this gear teeth in two portions. One is this portion, another one is this portion. So this top portion is known as face. This is known as face, and this bottom portion is known as flank. These are the various nomenclature of the gears. This is known as flank along the pitch circle. If I divide this teeth in two parts, this top part is known as face and this is known as flank. Right. Now let us see what are the various distances. Now let us see what are the various distances. First of all, let us talk about the distance between this addendum circle and this pitch circle. This distance. The distance between this addendum circle and pitch circle, this is known as your addendum. This distance between pitch circle and the addendum circle, this distance is known as addendum. Addendum. Right. And the distance between, we can say distance between your dedendum circle and the pitch circle, this distance, the distance between dedendum circle and distance between dedendum circle and the pitch circle, this distance is your dedendum. This distance is known as dedendum. Dedendum. This is known as dedendum. Right? We'll write it correctly. This distance is dedendum of the gear. Right. Now, the distance between your distance between dedendum circle and the clearance circle, this distance, right, this distance is known as clearance. This distance between clearance circle and the dedendum circle, this is known as clearance. This is known as clearance, right? So clearance means that we always want that the teeth or the tip of this mating gear, right, this gear will be in contact with another gear, so the tip of that gear should not touch this root, that should not touch this root. So we can say that the maximum point of contact is up to this clearance circle, so this distance is known as clearance. So that's why we can say that the distance between this clearance circle and your addendum circle, this distance between clearance circle and the addendum circle is known as your working depth. The teeth will be in contact with all the points, the teeth of the mating gear will be in contact up to this, from this addendum circle up to this clearance circle. So this is known as working depth. Working depth. Right, this is known as working depth. Now if I say, suppose, now let us talk about, suppose if I take the corresponding point, suppose at this pitch circle, from this pitch circle if I take this corresponding points of the two adjacent teeths, these are the corresponding points of two adjacent teeths, right, corresponding points of the two adjacent teeth, and this is the, let us say like this. Right, so this curve, if I write here, or we'll write with this, so we can say that this curve, the gear or this gear will be in this curve motion, right, this will be rotating. So this curve between the corresponding points of the adjacent teeth, if I take this point, then the corresponding point of the adjacent teeth is this one, right. So this arc along the pitch circle, this arc along the pitch circle is known as circular pitch, right. This arc along the pitch circle is known as circular pitch. Circular pitch is most important in the gear design. We will talk about this. This is known as circular pitch. And we can say that the distance, we can say the distance between these two lines, these are the distance. So we can say that this distance, what is this one? This is known as this distance, this linear distance, this distance is known as tooth thickness. The thickness of this tooth along the pitch circle is defined, and this distance between the 2 points of the same gear along the pitch circle, this linear distance is this is known as tooth thickness. Tooth thickness, right. And this distance along the pitch circle, what is there? When the another gear will come in contact with each other, so the one teeth of the another mating gear will be in this place, in this space between two adjacent teeth. One gear will fit of the mating gear, one teeth will fit in the space between this. So this is known as tooth space, right, tooth space of this gear for the mating gear. This is known as tooth space, this distance, right, this is known as tooth space. And this curve is known as circular pitch, or the length of this arc along the pitch circle between the adjacent, between the corresponding points of the adjacent teeth along the pitch circle, that is known as circular pitch. Right. So these are the various terminologies which we have to use in the gear when we are discussing the gears. Now let us talk about them one by one. We'll start with the pitch circle. Then what do we mean by circular pitch? What is the tooth thickness and tooth space we have to discuss. Right. Now, as we already discussed the various gear terminology from this diagram, so we can say that various gear terminologies or the various circles and what are the various radial distances we already discussed in this diagram. So now let us explain all these points, all these terminology one by one. Right. So first of all, I'll start with the pitch circle. Right. The most important circle in the gear design is your pitch circle. Now let us discuss about the pitch circle first. So I will see that the pitch circle is an imaginary circle. This circle is not existing in the gear, right, if we can say. So this is an imaginary circle where this pure rolling motion can be observed. Right, we know that in the gears we always want that a constant angular velocity ratio must maintain, and to maintain that constant angular velocity ratio we can say that there should be always pure rolling, that is the rolling or rotation without sliding. So the circle, when the two gears are rotating, right, when the two gears are meeting with each other and they are rotating, so the circle where this pure rolling motion can be observed, that circle is known as your pitch circle when the gears are transmitting the power. When two gears are in contact with each other and power is transmitted from one gear to the another gear, we can say that the pure rolling motion can be observed along this pitch circle. Right. So pitch circle is important because of this condition, because we can say that the pure rolling can be observed along this pitch circle. And the size of a gear, if you want to define the size of a gear, then the size of a gear is specified by the diameter of the pitch circle. And if you want to define or if you want to specify the size of a gear, then you have to say that what will be the diameter of the pitch circle, right? So the size of the gear is specified by the diameter of pitch circle. Now if we talk about the gear design, if we talk about the basic gear design, the gear design will be a part of your machine design syllabus, right? We will discuss about gear design there, but we can say that, if we can say in brief we can say that, so as a common sense you can say that in the gear design the condition will be that teeths in the gear should not be in fraction, right? Teeths should not be in fraction. Teeths will always be in integer, right? It is not like that the number of teeth on a gear is 3.5. That is not a way to design a gear. The number of teeths on a gear must be in integer, right? Like 3, 5, 16, 12. So the number of teeth should be in integer, and the interspacing distance between the teeth should be uniform, right? So that because we can say that if you manufacture a gear, so the thickness, the tooth thickness of each tooth will be the same in a gear. So if we can say, suppose these are the two gears, they will come in contact with each other, right? They will mate with each other. So if this tooth thickness, the spacing between the two tooths, right? This is the one tooth of this gear, another tooth, and we can say this is the spacing between the tooths. So if this is not uniform, then this gear will be either that if there is a space between them, then it will give you vibration, or if this space is less and the tooth thickness of this tooth is, or of this gear is more, then it cannot fit inside this, right? So we can say that these tooth thickness on a gear should be uniform. So this will be the important parameters when you are designing the gear. Now let us discuss about one important factor here. This diagram you will see again and again. So I am just saying, suppose we have two shafts. Let us say we have two shafts. Just pay attention. Suppose we have one shaft here. At this point we have one shaft, Let us say this is a point O1, and let us say you have another shaft here. Suppose this point is O2, right? This point is O2. Now we want to transfer the power from, let us say, O1 to O2, right? So O1 is my input gear, O2 is my input shaft, and O2 is my output shaft. Or then how we can transfer the power from O1 to O2? We can use gears. We can mount one gear on this shaft and one gear on this shaft, right? Now the gears which is mounted on the input shaft, that is known as pinion. In general language it is known as pinion, and this is known as gear, right? So suppose if I mounted two gears on these two shafts, and let us say this is the pitch circle of this gear which is mounted on shaft O1, right? This is the pitch circle of this gear which is mounted on O1. Pitch circle, I am just drawing the pitch circle, and suppose this is the pitch circle. Suppose this is the pitch circle of the gear which is mounted on shaft 2, right? So if I write, this is important, that's why I am writing, this is the pitch circle. Always we will define the gear with the help of its pitch circle. So this is the pitch circle of gear 2, or we can say gear. Suppose this is your input and this is your output, right? So this is the pitch circle of gear, and this is your pitch circle of pinion. Pitch circle of pinion. This is the pitch circle of pinion. Now where they intersect or they cut each other at this point, these both circles cut each other at this point. This point is known as pitch point. This point is known as pitch point. Pitch point. We will discuss the importance of this pitch point later on. So where these two pitch circles will touch each other, this is known as pitch point. Now if I draw a common tangent at this pitch point, common tangent to both of the circles, if I draw, suppose this is the common tangent at pitch point. This is the common tangent at pitch point. So if I write here, this is the common tangent at pitch point. Common tangent at pitch point. And if I draw a common normal from the pitch point, common normal to both of these gears which is passing through this pitch point, let us say this is the common normal. Let us say this is the common normal. Suppose this is your common normal. Just pay attention here. This is your common normal. Right, this is your common normal. Now just pay attention. We can say that when this gear O1, this is the input gear, when this gear will be in contact with this gear 2, right? So this gear will exert a force on this gear 2, this pinion. Suppose this is your pinion, right? I am just saying, suppose this is your pinion. The input gear is always known as pinion, and this is your gear. So when they will be in contact with each other, so this pinion will exert a force on this gear, right? So the force exerted by this gear or exerted by this pinion on this gear will be along the common normal, right? So we can say that if suppose this is the pinion, this is the gear, if they will come in contact with each other at this point, so this pinion will exert a force on this gear so that this gear will rotate. So this force will be in the direction of common normal. That is obvious. From the basic mathematics you can say that this force will be along the common normal. So suppose along the common normal, so we are not discussing about the directions and all. I am not concerned about the directions of the force and all. Suppose the force exerted by this pinion on this gear will be in this direction, right? Actually, if this is rotating like this, suppose this pinion is rotating like this, so the force will be in this direction, right? But okay, so let us say, so that you will not be in confusion, right? I can say that suppose this is rotating like this, this pinion is rotating like this, in this direction, with some angular velocity, let us say omega 1, right? So this will exert a force on this gear along this common normal, suppose this is your force F. The force exerted by this pinion on the gear will be F, and this common normal is also known as, we will discuss this later also, this is also known as line of action of force. Line of action of force. That means the force will be always along this common normal. This is also known as line of action of force. Force will be along this common normal always, right? Wherever will be the contact, right? Contact will be like this, no? This pinion will touch its tip and then it will be moving like this and then it will be disengaged. This is our path of contact, right? It will start like this and after that it will disengage like this. So always the force will be along the common normal, and this common normal is also known as line of action of force. So this force F will be always along this common normal, right? Now if I can say that why this common tangent is so important in the gear design, we can say, suppose the angle between the common tangent and common normal, this angle, the angle between the common tangent and common normal is, let us say, phi. Let us say phi. Phi is known as pressure angle. Phi is known as pressure angle, right? So if I want to find out what is the component of force F, what is the component of force F along common tangent, if I want to find out what is the component of the force F along common tangent, let us say the component is Ft along the tangent, it is Ft, this will be equal to F cos phi. This will be equal to F cos phi. Just pay attention now. So the component of this force along this common tangent will be Ft, which will be equal to F cos phi. This Ft is responsible for transmitting the power. You can see from here that this Ft into this distance, this radius will give you a torque, and because of this Ft into this, a torque is there, and because of that torque this gear will rotate. And if this gear will rotate, then this shaft connected to this gear will start rotating. This is the way of power transmission, right? So the power will be transmitted corresponding to this force along the common tangent. The total force acting will be F, but the power transmission will be corresponding to this Ft. We have one component along this direction, right? F will have a component along this direction. This is your normal component, so this will be equal to F sin phi, and this will be the axial force or the force on bearing, right? So we can say that this Ft cos phi will be responsible for transmitting the power. This Ft cos phi will be responsible for power transmission. Right, power will be transmitted because of this force Ft. So we always want that this force transmitted by this Ft will be as high as possible. Right, this Ft will be as high as possible. So if I can say that the transmitted force or the tangential force will be equal to F cos phi. So if this pressure angle is high, right, that means you can say that if your pressure angle increases, then cos phi decreases. That means the tangential force decreases. That means power transmission decreases. Right, so we cannot increase the pressure angle up to a certain level. If you increase the pressure angle, then the transmission force will be decreased, and as a result power transmission will decrease. So we can say that maximum phi value will be between 20 degree to 22 degree. Maximum value will be between 20 degree to 22 degree. You cannot increase the phi more than that. Right. So this is the basic gear design. You just remember this diagram because every time we need this diagram in the gear analysis. Right. So these are the pitch circle. This is the thing about pitch circle.